All right, so just like we had rules for sums and differences and constant multiples of derivatives, we have analogous rules for sums and differences and constant multiples of antiderivatives. And so um, these work out nicely. Like I said before, there's no product rule, there's no quotient rule. But the sum and difference rule that works out pretty well, and constant multiple we can just pull that constant multiple out and find the antiderivative of the function. So let's look at example 5 and let's practice using these rules. Okay, so the first one, we're finding the antiderivative of x cubed plus x. Okay, so we have a sum here. Whoops. We have a sum. And so I can use the rule and I could rewrite this as the integral of x cubed, integral of x cubed dx plus the integral of x dx, right? And then I could just find the antiderivative of each one of those. Now, this is going to give me x to the 4th over 4, right? Now, I could put a plus c, but I'm not because I'm going to have another plus c here. So this gives me x squared over 2, and then I'm going to add a plus c, right? Because if I have two arbitrary constants and I'm adding them together, it's just another arbitrary constant. So I'm just going to use one arbitrary constant for this antiderivative. All right. So so we just broke it up into two integrals. Although you don't need to do that. If you know that you're just going to add the antiderivatives, then you could bypass this step where I broke it up and wrote it as two integrals, right? And just find the antiderivative of each term in the integrand. Okay? All right, let's look at this next one. Here we have a constant multiple of an exponential function, right? So I can rewrite that as 3 times the integral of e to the 0.5, e to the 0.5, e, come on, stay, to 0.5x dx. dx. Okay, so I just pulled the constant multiple out, and then I know that the antiderivative, I'm going to hang on to that 3, and then the antiderivative is going to be 1 over, I can write it as 1 over 0.5 e to the 0.5x plus c. Now, if you remember, 0.5 is a half, right? And the reciprocal of a half is 2. So probably a nicer way to write this would be 6e to the 0.5x plus c. Okay. All right, let's look at this next one. Now we have x plus 1 and everything is divided by 3. All right, so that is just the same as finding the integral of 1/3 x plus 1 dx. Okay, that's the same thing, and then I can pull that 1/3 out, right? I can pull that 1/3 out of the integral and take the antiderivative of x plus 1 dx. Okay, I got two terms, but I'm not going to bother breaking that down into two different integrals because I'm just going to take the antiderivative of each term. And so I'm going to get 1/3, and it's times the whole antiderivative, so I need parentheses. So I'm going to have x squared over 2 plus x, and then plus c. Okay, now I could leave it like that, or if I want to simplify it maybe a little bit, I guess it would be x squared over 6 plus x over 2 plus, oh sorry, not 2, 3, hang on, 3, I want to make that a 3, 3, plus c. Okay, so there we go. There's the antiderivative for that. And then finally we have some trig functions here. Again, they're constant multiples. So I could break this down into two integrals and then pull out the constants, but essentially you're going to hang on to that constant, right? Hang on to the constant and then find the antiderivative of sine, which is a negative cosine. Now I'm multiplying, okay? So don't write negative cosine. Whoops. No, don't write this. Don't write this. I've seen people do that, and that looks like you're subtracting, right? That's not right. All right? We're multiplying. We're multiplying, so I'm going to put the negative out front and cosine of x. Okay? And then, again, I'm now going to find the antiderivative of 5 cosine. So hang on to that constant, and then the antiderivative of cosine is sine of x. Okay? And then plus a c. And we're done. Well, no, we got 2 more on the next page. Let's go ahead and do the next. We're done with that one. Let's go ahead and do the next, these last 2 on this, on the next page. All right, now these, let's see, this one definitely requires us to rewrite it, right? Because remember, there's no quotient rule. And so if I'm dividing this whole numerator, x squared plus 2x minus 1 by x, that is going to give me, so x squared divided by x gives me x. 2x over x gives me 2. And then I have, minus 1 over x. All right, that whole thing times dx. All right, so all I've done is now rewritten the integrands so that I can use the rules that I know. And I'm just going to find the antiderivative of each term, right? So now I'm finding the antiderivative, so I don't need the integral symbol anymore. All right, so the antiderivative of x is x, right? Because it's x to the 1, right? So I'm going to just take the exponent. I can treat it like x to the 1. I'm just adding 1 to the exponent and then dividing by that n plus 1. And then I have a constant, so that's going to give me 2x. And then I have minus, and then it's 1 over x, so it's the ln of the absolute value of x. Don't forget the absolute value. And then plus c. All right? So when you take the antiderivative of 1 over x, don't forget that absolute value. It's important. Got to keep that on there. All right. Let's look at this last one. So, all right, what do we do? There's nothing really we can do to simplify this, except maybe pull the 2 out of the denominator. All right, so I'm going to do that. So I see there's a common factor of 2 in the denominator, so I get 1 plus x squared dx. All right, now dividing by 2 is the same as multiplying by a half, right? So I'm going to pull that 2 out of the denominator, and that's going to give me 1/2. So this is the same thing as 1/2 integral of 1 over 1 plus x squared dx. Okay? Whoops, jeez. Okay. All right, thank goodness for Control Z. All right, so now, now, what do I do with that? So I got to think back. Do I know any function that has a derivative of 1 over 1 plus x squared? All right, so you should recognize that as the derivative of inverse tangent. And so we're going to have 1/2, right? We're finding the antiderivative now. And the antiderivative is going to be inverse tangent of x. And then plus a c, of course. All right. I'll meet you in the next video.